Hello and welcome to Nerdy on Real Dev. And today's video is going to be a bit different as I got a request from Antonio about my thoughts regarding Unreal Engine 5 photorealism lighting and post-processing, especially regarding Lumen and Nanite. So thank you, Antonio, for the question. For those who don't know, Lumen is Unreal's new way of lighting. They recently did a video that went more in depth into Lumen, which also allowed me to have more thoughts. And Nanite is how Unreal figured out importing extremely high poly models. I would have loved to show you that within Unreal Engine 5. However, apparently my system of i7 CPU, 1060 GPU, and 32 gigabytes of RAM was not enough to import a 6 million polygon model, let alone a 26 million polygon model, which tells me I should go a bit smaller, but I wanted to get this video out to you. So while I'm talking, I'm just working on a scene involving the Unreal water bodies, as well as some megascans, since Unreal Engine 5 manages to not crash my computer when using megascans. So, moving on. So Unreal Engine 5 involves essentially they're doing this cool thing, and once I get some more plants, you'll be able to see it a bit better. But what Lumen is able to do is reflect the colors of an object onto another object. So actually, let me just, since I'm in there now, there is a possibility this won't work because I am not running a GPU that has ray tracing, and it is a little, they are trying to do their best to have a lot of this lighting stuff be able to work on 1060s and below, since due to the current GPU crisis, ray tracing isn't available for everyone and isn't gonna be for a while. That reason is why my scalability is still on low. However, the fact that you can have objects reflecting the color of another object, not that one, is huge. Because in real life, light, so we're all aware that light bounces. That's why you have things like a skylight that grabs all the sort of colors and ambient stuff around to help reflect that. What Unreal Engine 5 is doing is it's essentially having it so the colors of objects reflect onto other objects. See, we're not really getting that now. I have my scalability on low. However, why don't we bring some of this a bit higher? You can already see some changes happening. Shadows, that's a big thing. Post-processing. The only thing I'm keeping low right now is, alright, we'll bring that up a little bit, and shading. And already you can see on this chrome sphere, I did not rebuild a single thing. There are no lighting rebuilds. And you are just automatically getting this wood reflected. And that is actually huge for photorealism because the light is really weird. And getting it to work properly in real time has definitely been a challenge. So able to do more things with it. So let me just bring this office to the beach, this very rocky beach, because sometimes you need to work on your stuff while you're on vacation because your bosses forgot that you're on vacation, and automatically do believe I have a reflection capture that does help with this. Whoops, you can see some of my games programs. There is no lighting rebuilding, so that's gonna help. That just helps a lot. There is some odd flickering going on and a bit of fuzziness. I believe that has something to do with, yep, some of this. Those of you with better GPUs will have a better luck with this. But so in the shiny chrome sphere, you are getting reflections of the environment, like good reflections of the environment. And that's another thing that Unreal Engine 5 is doing that's hugely benefiting photorealism. Because in order to get these sort of exact reflections, you had to do all sorts of tricks. There's a reason that in Resident Evil, 8? Lady Domestic, big vampire lady, smashed the mirror. Because to actually have the mirror in-game would require so many resources just to have a proper reflection. And yet what we're seeing is real time. There is a reflection. It's a little off and it's changing as you're moving things around. It's a little fuzzy. That's because of the material. And also there's a lot of computation going on. But there are settings you can change to affect that. So that is a huge thing. Also, part of why I was bringing out all of these props is because the shadows have improved greatly. Even on this 1060 GPU, these are more like actual shadows, where you can actually see. You can see. Because that's the thing with shadows. They're not completely dark. You can usually see shapes of objects. Things are darkened, but it's not invisible. And this is huge for photorealism because shadows and getting the light to bounce properly is huge. It's like in their video showing off Lumen, the differences between Unreal Engine 4 and Unreal Engine 5 might look subtle to some, but those are just amazing. In fact, Lumen and Nanite don't seem to be bringing in too many limitations. They seem to be raising the bar as far as real-time graphics go. And as more and more movies start using Unreal to help with their VFX pipeline, that's massive. As far as Nanite being involved, that's where some of the limitations actually are. Because Nanite, essentially what it is you import your model. Apparently not a 6 million polygon model, at least not with my setup. But you import a model, and what Nanite does is it groups all the tries into... It just takes all the tries and puts them into groups. And it automatically sets up LODs, which even if you're not necessarily making a game that requires Nanite, like constant high polygon models, it's still incredibly useful if, say, you're making a game that requires a whole ton of LODs and you can use Nanite to just make them quickly. However, the thing with Nanite, at least at this stage, it's possible this might change as Unreal Engine 5 is still in development, is only opaque textures work. Now that's most props. Most things don't require translucency. However, you cannot like use Nanite for, say, glass windows. Or anything involving translucency, you cannot use Nanite for. You also cannot use Nanite for animated meshes. So, sorry character artists, this is static meshes only. Which means some of this sort of cool stuff with Lumen might be limited with Nanite just due to a lack of translucency. But it shouldn't be too big of a worry. Another limitation with Lumen is emissives. So I love working with emissives. I don't know why. I think it's just because I like glowy sci-fi stuff. But Lumen currently has difficulty with small emissives. So if you have like a big light, like a big square light that's emissive, you can use that. That can be your light source. However, if you have a small emissive, while it could be a light source, it would still have flickering and texture issues. So you would need to do the typical having a light nearby in order for the light to actually shine. But there actually aren't as many limitations except for GPU use. Because as many of you have noticed, I've mentioned my GPU several times. This totally isn't begging for a new one. But there is a lot going on here that involves ray tracing. I am impressed with my 1060 that I am able to get this level of reflectivity, even though there's a bit of fuzziness going on. I mean, it also seems to be detecting the ocean movement, which is really cool. But you can get even better shadows, even better reflectivity, even better global illumination if you have ray tracing. That is the big thing, because even though the current light source is in a way moving away from ray tracing, like it's, how do I re-explain this? It involves a lot of the same computations as ray tracing, which means you need GPUs that have ray tracing enabled. They figured out how to do some of it without it. I believe in editor preferences, where we've got a whole bunch of stuff, color vision, experimental. We're just gonna search. Nope. There is a whole bunch of stuff here. In the video, they showed how there's two ways of doing the lighting. There's the software dependent, which allows the computations to be done on a 1060 or lesser. But you can select hardware enabled, and that allows use of any ray tracing enabled GPU to get even better computations and shadows and all of that. So there is that. And overall, I think all of this is really cool, especially the more I see that I'm able to do on my 1060, even though I don't have the ray tracing. um, but a lot of this, I feel like, is still intended for movies and CAD. The reason I say this, and this was my suspicions when I first saw Lumen and Nanite, is because the process there involves a lot more high poly models and a lot more realism to avoid tripping people's "this is VFX" radar. And even with today's release of 4.27, a lot of the advertised features, even though it did involve a lot of under the hood stuff that's great for game development, was stuff for movies and TV shows like The Mandalorian that are using Unreal for their VFX process, because you need to be able to change the lighting on the fly. The lighting needs to be able to reflect the people around it. And I will say the reflections do work on characters. So the colors will reflect. And the end display stuff, a lot of that is more entertainment based. This can be used in games. This can be used to make your game look absolutely gorgeous and the highest tech. This can be used in funky ways for stylized games, especially if you're going for like a cyberpunk aesthetic. But it does have a cost, because while supposedly Nanite and all this is supported on 970 and later GPUs, in fact, I think a little early, as long as they have something called Maxwell, it's still, you're still risking a lot of optimization difficulties. For those of you thinking, well, yeah, it's going to make my hard drive 100 gigabytes if I use Nanite models. No, because they do have a compression system. So your 1,000, or not 1,000, that's normal. If your million polygon model is turned into Nanite, it will only be a few megabytes, like 226. It won't cost a lot hardware, like space-wise. But for the system to do all of these reflection computations, that's a lot easier, for one thing, if you have a render farm. It's a lot easier if you're doing it one time to show than for a game that has a whole lot of programming and other elements involved. So I feel like this can be used in interesting ways, especially since the initial Unreal Engine 5 demo showed Lumen being used alongside Niagara. That kind of interactivity could open all sorts of game mechanics. But overall, I feel like this is more for the movie and CAD industries. Though, by all means, fellow game devs, prove me wrong. Prove that you can make Nanite and Lumen games that have all the photorealistic and post-processing that can run on, not a Switch, It's highly unlikely it'll run on a Switch, though if you can make it work on Switch, kudos. But so basically, it unlocks a lot of possibilities for games, both stylized and photorealistic. But overall, it's for movies and CAD. Hope this sort of rambly video where I'm showing stuff was fun. And do have a little advertisement coming up. But if you want to support me, either... either click on the affiliate Clip Studio link or go to my coffee and buy me a coffee. Maybe I'll even get enough for a ray tracing GPU and be able to show you guys all sorts of cool stuff. Have a good one. Of course, not all game dev work involves 3D. From concepting out VFX, creating a forest background, and creating images for that visual novel of yours, Clip Studio Paint has your back. With a variety of brushes and tools such as posable 3D models, animations, and more, Clip Studio has everything you need to help make your game a reality. Click the link in the description to get your own copy of Clip Studio, either with a one-time payment or for those on iPad or tablet, a subscription as low as $24 annually.